Okay. So yeah, thanks a lot for that introduction. Definitely an honor to be here among a lot of really good speakers. Today we're going to be talking about this new concept, of course, affectionately called Blurple teaming. Not intended to be serious, but the title itself hopefully indicates that we are starting to uncover I think some new futuristic, if you can, ways of approaching how we're doing defense, and a lot of that comes from the offensive perspective. So I hope people get some value out of today's topic. So let me jump into the deck. So quick thing on who I am. I'm the CTO here at Prelude Research. My background is kind of all over the place, but mostly on the offensive side. If you're familiar with a tool called Caldera, that was kind of my baby for a few years while I worked at MITRE. So I built the second version of that and third version and so forth. My handle on GitHub is Private Ducky, if that's one you've run into. I was also on the attack leadership team and a few other projects there at MITRE. Worked at places like FireEye, Mandiant, John Deere is listed here, Kenna Security, Rockwell Collins, and a number of other defense contractors within the US government. And so my background is largely offensive security, doing a lot of things that are either on the operation side or on the red team and emulation sides over the years, doing it about 17 years. And so a lot of the concepts that you're going to see here are kind of a continuation of projects through the years at specifically at Mandiant, MITRE, and now here at Prelude. Before we dive into some of the new stuff, I want to set the stage on how we approach purple teaming today. So really three phases, if you will, of a typical purple red team operation. So you have a planning phase, an emulation phase, and a conclusion. Now, looking at kind of the purple, red, and blue sections here, these obviously fluctuate in colors and who's responsible based on a number of factors. But the key thing here is every assessment generally starts with a brainstorming session or who are we going to target? What are we going to emulate? What are we actually testing here? That combined with logistics, where are we going to target it within the organization, tends to be the beginning of your purple team assessment. That goes into potentially a tabletop exercise of kind of sketching out how you anticipate, try to predict how do you think this is going to go? Why are you actually performing this exercise? And then you go into the actual offensive portion, which is the development of the capabilities. What are we going to test? Are we going to pull off the shelf atomic red team atomic tests? Are we going to develop our own in-house? Are we pulling from a MITRE Ingenuity playbook and so forth? That emulation then turns into physical attacks. We're going to convert that into from computer code into an actual thing that is run by an agent. That then moves over into the detection phase, which is, are we detecting these things? Are we catching them? Are we preventing them in some cases? And then that goes into the conclusion where everything centers around the event called the hot wash, which is get your final report. Let's go ahead and have the red team talk about what occurred, do a retrospective, kind of start over. And this start to finish exercise can last anywhere from a few days to a few months, or longer in some cases. And the key here is the targets, the logistical portion of this is almost entirely at a very small scale. This is where I think we're missing the mark in a lot of what we do from an offensive side today, which is we target a small N. We'll target one machine in some cases. Large organizations may target even a single machine as part of their operation. Other organizations may go up to a few dozen at most. Most I've seen a couple hundred as part of some orchestrated operation like this. But the true count is a fraction of what an organization has from a totality of endpoints. So if you consider a large organization with Windows laptops and Linux servers, maybe point of sale devices that are IoT, and a variety of things running in the cloud, Lambda servers, firewalls, and so forth. The devices that are part of this type of purple team assessment make up a very small amount. Now, the argument for that has always been you can test on very small N of machines and then extrapolate what that means to a larger N. So if I can test on 10 machines, I can extrapolate the results to mean X on 100,000 machines. And that is true to a large extent. And I think that becomes true in the sense of the law of large numbers, but there are a lot of edge cases to that theory in terms of the important things, the edge cases, the servers that are just sitting there. All you need is one kind of mistake in that sort of theory in order for a real attack to have significant repercussions. So the first area we're going to look at is how do you actually take this concept of going through these very valuable phases and then increase that n size of endpoints. One of the best examples I like to give in this sort of realm is kind of pulled from my own experience, which still works by and large today, which is when I go out on an operation or a red team assessment and I get on my first machine, one of the first things that I approach doing is tinkering with the device that I compromised in order to disable the EDR or endpoint defense in a way that is atypical. So you've all heard of unhooking and all sorts of evasion techniques you can do with an EDR. I actually like to go much more rudimentary than that. The approach I like to take is tinkering with the device settings, specifically how the hardware is running. So for example, I will write a quick 2 or 3 line script that will increase the CPU of the device in order to make it busier than normal. And it sounds very benign, and it is, but it has a few after effects, one of which is dropping packets on the EDR side, as the EDR is now forced to prioritize what it evaluates into what level of depth. And so something that simple can kind of highlight the fact that extrapolating results from 10 machines to 100,000 machines can be tricky, because all of these sort of scenario or environmental concerns kind of kick in, and those become incredibly difficult to find it as something as complex of a topic as what you see on screen on a very small n. And so those are the reasons why running this sort of emulation, this sort of test on every machine in a continuous basis is the best approach to being able to locate all of those hidden corners, if you will. Now, in order to do that, of course, you need a very significant safety guarantee and a very automated process for doing this, which is what we're going to talk about. The first thing to consider when you're looking at a system of continuous testing and you want to take that type of system that we just saw before, that type of process, and start scaling that up to a large N, is you need to determine a format of what you're going to test. Now, I've got on screen here Assisted Advisory, recent one that came out for a specific ransomware strain. Now, how do you determine what you're going to test in a repeatable way that can be agreed upon? Now, there's generally 2 schools of thought or 2 ways this occurs within an organization. It is what is of high impact, and it is what is the CISO or other executive directive actually wanted. Now, these 2 could be perfectly in sync, or often they are 2 separate parallel tracks, and the security team has to accomplish both. Now, from a CISO directive perspective or an executive directive, usually they're concerned with current events. So something that just either occurred in the organization from a security standpoint, an event that occurred, maybe a recent compromise, or something they read in the Wall Street Journal that triggered their thought, and they said, hey, I wonder if we're vulnerable to that thing. That's a very common sort of work stream. The second one is high impact. That is very subjective. That's squishy. You can bucket high impact under the CISO directive column, if you will. But high impact could also be a security team that just knows where the vulnerabilities are and the general weaknesses of the organization and has a game plan for what they want to test that will match up to that really well. The important thing here is you kind of look at this from your own organization perspective, is how can you develop a system or a model that determines what you're going to test in a way that really aligns with the organization. It's important to get that general agreement. For example, here at Prelude, we develop a lot of security tests. That's kind of what we do, right? And at organizations I've worked at in the past, like at MITRE, when I wrote Caldera, we wrote TTPs. That was a thing we did. Now, each one, we could basically take the Linux Bible and grab every command in the book and do all the different interpretations of that in different languages and different variations. That's one way, and you can run every variation against machines, and it's very noisy and so forth. But The other way is you choose these high impact events and really focus your energy there. So what we do at Prelude, for example, is we prioritize CISA advisories. What we're doing is we're piggybacking on the fact that CISA is going through and as a government agency, locating and understanding the high impact events that are occurring worldwide, and then publishing them in a generally a consumable way, which is generally about 2 to 4 advisories a month come out on the cybersecurity side. That's one that I've looked at over the last couple of years as this kind of system and process has been developed at CISA, and said this actually makes a lot of sense, that velocity is something that I think most organizations should shoot for, which is 2 to 4 times a month, being able to look at an advisory like this on screen and say, are we actually vulnerable to this thing? And if so, to what extent? All right, so as this applies out to the greater SOC, and you look at taking the system as we've chatted and said, how do we apply this at that greater end? We know what we want to test. We want to test CISA advisories. Maybe we want to test specific attack, MITRE attack techniques, right? Could be anything. You develop that model and that kind of opinion. And you say, okay, I know what I want to test. Now, how do I accomplish it? There are 3 components that you really need to account for. The first one is the thing that's going to be the executor, if you will. So we've all heard of TTPs, tactics, techniques, and procedures. These are generally just obviously procedures, the thing that you're actually executing on the endpoint. That's generally the agreed upon thing, right? In the beginning of my career, TTPs as an acronym wasn't really popular. It was more attacks and payloads from a terminology perspective, but it's the same concept. It's I have a piece of code or a file or an executable or a binary or something that I want to detonate in some form or fashion on an endpoint and gather the results. TTP could come in that form. But again, inside of offensive security, we haven't done a great job as a kind of a sub-industry at creating structure around this concept. It's very complicated. It's a very hard problem to solve. But this is why TTPs can still come in many forms and formats. In a large way, that is still very justifiable today, though, because that's what you see in the wild. The second thing you need in order to pull this system off is you need something to execute the test in the first place. So you have agents, right? We've all heard agents. You have the concept of an endpoint agent that is a command and control, or a RAT, a remote access Trojan. You'll see the terminology we generally use is probes, which we'll talk about in a minute, which is a new concept entirely. It is parallel in thought to an endpoint agent, but there are some unique characteristics to what a probe is instead. And this is something, again, you can replicate yourself from a conceptual standpoint. The third thing you need is infrastructure. In order to test continuously, you don't want to use a command and control center as it exists today. Command and control centers, by and large, I mean, I've written many, including Caldera, are not designed for the type of scale of running on every machine. They're intended and purpose-built for that smaller N. And so when you look and say, hey, how do we move up and start testing on that greater scale? You want to account for infrastructure. So there's 2 parts of that you really want to weigh. You have the scale, which is the obvious one. If I'm going to have 100,000 endpoints connecting in that are capable of collecting these TTPs and tests to run, I need a system that can handle that amount of network traffic to even contemplate this. The second thing that you need was actually a little bit more implicit. This is, you need an intelligent engine that is capable of understanding what tests go to which endpoints. So as endpoints are looking for tests, you need that intelligence, or at MITRE, the research we did was in automated planning, how to develop models around autonomous decision-making. So you need that sort of intelligence factor built into the infrastructure that can support things like scheduling and handing out tests. Let's look at each one of these a little bit closer. So TTP. So on the left-hand side, you're going to see a TTP. On the right-hand side, you're going to see what we're calling VSTs, which is a production version of a TTP, a verified security test. Now, a TTP, this one in particular, these are, by the way, this is the exact same command shown in both examples. The left-hand side is actually the exact same replica of a TTP I wrote for Caldera originally, and then ported into Operator a couple of years ago, which is another command and control center. This TTP you can see has a variety of metadata components to it, really just for the author and for organization standpoint. And then you see the meat of it under platforms, which is going to list off here. The Windows platform is supported, and you're going to see PSH for PowerShell, which is what I used to refer to as the executor, the thing that is on the box responsible for running the command itself. And then you can see a PowerShell command, which does the actual thing. Underneath that, you can see the Linux variation of it. Concept, this is very similar with Atomic Red Team as well. They have a giant collection, very useful test space for this sort of thing. And you can see here, you're able to use this sort of format in order to develop as many sort of commands as you want. It's pretty flexible. You can do more than just PowerShell and Bash. You can plug in commands of any language. On the right-hand side, the version here, the VST, is a little bit different. This is a piece of code written in Go, intentionally so it will compile into a fat binary, which gives you the ability to golden image this. You can hash it, you can understand what it is, and make it immutable. The second thing to note outside of that is the reliance on something called the endpoint module, which you can see in the import section. Inside of here, you'll see that endpoint module is in the test. You'll see inside the test function, you'll see the endpoint module used, which is a collection of shared functions that understand how to run functions on or behaviors on the endpoint. So in this case, the first one we run into is endpoint.shell in the test function. This one is a common function, as you would imagine, that knows how to run shell commands. Pass in any Bash, PowerShell, anything that's going to run within the terminal of the machine, knows how to run it, return a response. Variety of other kind of endpoint related functions exist in that module. Now, the other and final key thing to keep in mind on these VSTs is the fact that each one has a test function and a cleanup function. The cleanup function is intended to reverse the effects of what occurs in the test. That is, if there is something in the test worth reversing. In this case, there is not. The cleanup is something that is worth a slight bit more information on. So I wrestled with this concept when I was building Caldera, really throughout the whole process, which is if I list a cleanup command in the TTP file, the fact that it is disconnected, which was by design for best software practices, from the agent that is running the test, the TTP, you can't control the way the cleanup is going to run. The cleanup actually has to be done in tandem with the thing running the test or the TTP. When you take a few steps back and you think about why that is, you can consider a typical command and control center where you run a test. Let's say that test adds a new registry key on Windows. You go ahead, you add that registry key. Let's say that process of adding the key works, but that triggers the defense and the defense shuts down that agent. That agent is now unable to execute the cleanup function that it wants to do next in order to reverse the effects. And so that delicate sort of counterbalance needs to be accounted for as you're looking at how do you actually package up one of these TTPs into a production grade version. And VSTs cover that through this process that you see here with the test and cleanup kind of coupled together. But these are also integrated into the second piece here, which I'm actually going to skip ahead real quick, into probes. Now, probes are the things that are running the tests. Now, these understand how to execute the tests as they are. They also understand how to execute the cleanup functions and ensure they get run. Now, that is one obviously really big benefit of the probe, but another couple of key ones are the lightweightness, which is what makes them probably at first glance the most unique, which is a probe is measured in kilobytes. A probe generally, at least the ones we've written here at Prelude, range between 30 lines of code and 60 lines of code. They're very, very tiny. Probes have no dependencies outside of the standard language that they're written in, and they know how to do only one thing, which is run security tests. Now, the key part of a probe is that it runs obviously itself in a specific process. So it's running as a process on a machine. By the way, because they are so light, they can run in memory, they can run inside other processes. They're very flexible units. But the concept is that the probe is running in a process. Every test that it executes is run in a completely separate sub-process of the parent. Now, that's really important from a perspective of running Purple team assessments at a really high end, because you don't want the probe itself, the endpoint agent, to be shut down by an EDR or defensive control. So by whitelisting the probe itself and allowing that to exist, you can focus the energy of the defensive agents and so forth on the tests that are running. So as tests kind of run through the probe, the EDR can shut down any test, any process, act on those sub-processes naturally, and try to discern which tests that are running are benign versus those that are actually doing sequences of behaviors that should be shut down. So that's one of the key aspects of the probe, and one of the things that really distinguishes it, I think, from an endpoint agent. The last bit here is to note, because probes are so single-minded, if you will, single purpose, which is they just want to run a test. They intentionally avoid C2 capabilities, things like reverse shells, things like running through proxies and chaining themselves together in peer-to-peer networks. These functionalities that exist for evasive, largely evasive reasons, add bloat to the endpoint agent. And as you add bloat, you start to add things like dependency, lines of code, and a risk. You add safety and risk concerns. So by removing all of that, focusing on the single purpose, you're able to have a probe or a process that is so lightweight if it's within a kilobyte size file. You can see 4 probes listed here on screen that we've written here at Prelude. These 4 are open source. All of the kind of a side note on what we do here at Prelude is our kind of view is if the code runs on your computer, like a probe or a test or something to that effect, code's open source. So the code for these 4 probes is completely open source. You can check it out. You can see the operating systems that are supported for these different probes and the relative sizes of each. I'm going to back up one slide to show exit codes. So I skipped over this one. So this is quite critical, actually. So every test, when it runs, and you'll actually see this in this first slide here, where you see the test function itself stopping, calling this endpoint.stop with a 101, which is a curious number. And you can see the same thing down here, stop a 100. That curious number can actually be traced to a lookup table that will tell you what that means if the test exits at that point. This is actually, I think, very, very interesting for running on a high N, which is the typical Purple team assessment process or Red team assessment is you run the test or the TTP on an endpoint that generates an arbitrary text output. That output then needs to be understood by a human being, or today, maybe an LLM. But you need to understand that output and then use that information in order to make a decision. What do you do next? What does it mean? That is where the security reporting problems have come in over the years, because that process is hard and subjective. So what tests are intended to do is bypass that and not send in any arbitrary text from the endpoint. Instead, every test exits itself with one of these codes off the lookup table. Every code explains the very granular thing that occurred within the test. Now, what that means from a telemetry standpoint is only a 3-digit code is sent off of the endpoint. There's no private information, there's no passwords, there's no standard out, standard error, there's nothing. There's just a 3-digit code that describes what occurred during the test that the endpoint was asked to run. Now, that adds a significant amount of safety measures around what you're doing, along with privacy and what's going over the network. And it also allows you to run at a high scale, because the amount of data flowing across the network becomes significantly smaller than it would have otherwise. Okay, now all of this kind of centers on this concept as we started of Blurple teaming. So Blurple teaming, as we see it, is the ability to take that initial Purple team process that we're used to running on this small n and extrapolating out, running it on every endpoint within your organization so you have eyeballs everywhere. Now, that sort of process is not the norm. That doesn't happen, right? We're used to those research labs and development environments and extrapolating out. Now, there's a few key characteristics to Blurple teaming outside of the N that I think are really important. The first is self-healing. If you were to just turn a system like this on tomorrow, what you would notice is you would have a lot to do as a defensive security practitioner. You would notice all sorts of things happening in your environment that you would want to fix. It would be like the lights being turned on. I gave that example of the CPU before. You would see that in 50 different variations spread around your network, and you'd be looking at all these different aspects and saying, man, I didn't know that if you created a condition like that would be the effect. Another example is updating of the EDR. If the EDR updates, a lot of times it actually will turn itself off or switch policies that it's running under. And a lot of that can even come down to things like time of day, if that overlaps when the NTP is on the box is also updating. These conditions kind of come under light when you're running at this sort of scale. So in order for Blurple teaming to be really successful, it needs to include self-healing. Now, this actually is one of the most, I'd say, primal things that I hold on to, which is I believe that companies that are consuming security products are bearing too much responsibility. They are having to staff up and understand and build security teams that can comprehend all of this information and intelligence and figure out how to use tools to protect themselves versus relying on the vendors that they're buying security from to do that work. That is one of my kind of fundamental beliefs. And through the self-healing part of Blurple teaming, the concept is to rely on the vendors and to create a self-healing loop that every time something wrong happens, a test runs and the test is not protected against. Let's say a test that I write emulates a ransomware attack. The ransomware attack is not caught. Instead of the organization, which may not do security as a professional, organization, instead of the organization having to fix all of those problems, that unprotected result should be sent to the EDR, the vendor itself that failed during the operation. And that EDR should then kick off a process that attempts to fix that issue. It could be a behavioral detection miss. It could be a static antivirus miss. They should look at that as the security vendor, figure out how to fix it, roll a fix in to their own product. And then when that test runs again tomorrow or next week or next month, you should see that resolve itself. That should be the general concept of what I call Blurple team, purple teaming. Another way to think of this is as a utility. So if you think of, let's use your water bill, right? We probably all get water bills. I can probably garner a guess that the only time any of us ever log in and look at the water company's website is when we missed a payment or originally set up the account and figured out how to turn on autopay. Utility company websites are generally not thought of as amazing designs or very high utility in their uses, right? They're there in order to set your account up, and then you turn the faucet on at your house and you expect to see water come out. Security should in a large way actually follow that model, which is a very complex topic, such as serving water to a house is very complex, but all of that complexity should be buried under vendor solutions that actually work and that you can trust. Those are two things that we lack, I think, as an outer organization today, is that trust on the vendors. And so that's why we bear this responsibility. But in Blurple teaming, the goal is to shift that responsibility so we can start to look at security more from that utilitarian perspective, more as a utility itself. And we can just trust the fact that that is actually happening behind the covers. That way, when events happen that are really significant, we don't get overwhelmed with alerts and notifications and things to do. we're paying attention when the really important stuff happens, at whatever cadence that happens to be. The only thing call out I'll put on this page is that alert management, which is something that you want to do when you set up a Blurple teaming environment and you start to run this at the scale that we're talking about today. Is if you were to run these offensive tests without doing this, you're going to get tons of alerts happening in your SOC and your SIM. And you want to make sure your correlations are set up in a way that those tests are managed and triaged appropriately. You can do that through a number of different EDR vendors. You can do that through Splunk, but you want to make sure that you are accounting for that. Now, this is kind of a visual representation of how we do it at Prelude, but you can kind of consider and think about how you would do this in your own organization, which is at the center, you want to run your probe next to your EDR. So in this case, I'm showing CrowdStrike Falcon. Now, it's important that you run the probe wherever the EDR is, because at the end of the day, what are you testing primarily? You're testing the endpoint defenses. What does that entail? Entails testing the EDR along with other things, but the EDR is obviously bears a large part of the responsibility here. So the probe runs where the EDR runs. Now, the second thing is you ask a question. We talked about that. What do you test perspective at the beginning of this talk? We see that off to the right. Where are we vulnerable and where do we harden? You may ask yourself this question and say, okay, well, what does that kick off in Blurple teaming? Well, that kicks off a test. And we can see what the next stage would happen is Prelude would, in our case, select a test for the probe and say, you know what? You care about this advisory. Here's this test. Go run that. That runs next to the EDR, and the probe itself measures the EDR's responsiveness or lack of responsiveness to that test, reports a protected or an unprotected state back to the actual EDR itself and the vendor itself. And that allows them to make a decision. Do they need to add a new IOC into their detections? Do they need to add a sequence of behaviors to their IOAs? What patches might need to happen within that EDR agent or account for environmental concerns, right? They can now get the information they need in order to try to resolve the issue. And the whole concept of Blurple teaming is continuous and at scale. And so if this is continuous, as soon as this test is reported as, say, unprotected, you can know that that test is going to continue running until you get a protected state. So that will create a loop that continues to go until you can see that resolve itself. So I was going to pop over and do a demonstration of a kind of a live loop, but I know I'm short on time. So I'm going to just leave it here at this slide. We do offer a free service here that you're able to pop in and use if you want to take this for a spin and kind of get a feel for how we do it here at Prelude. Like I said, the probes are open source. The tests are completely accessible. Read the source code of all of those, and you can kind of get a picture of the reporting in the dashboard here from that continuous security perspective. So I definitely encourage people that are looking to try this out on their own environments. Take this for a spin, see how it feels, look at how you can extrapolate or scale up this sort of approach into your greater organization. But I know I'm running short on time, so I will pause there and open for questions.